as much as possible, you need to protect your code from unforeseen errors. And one of the ways of doing this is to use the built-in exception handling that's provided by Delphi and by Lazarus using free Pascal. Here I've got a Delphi project to show how to do some simple exception handling. It's the conv-x project, and I've got a form with 4 buttons on, and each of these buttons deliberately creates a problem that has to be handled. So exception 1 just says there's been a problem. Exception 2, there's been a conversion error. That's a specific type of exception. Exception 3, another type of exception, a zero divide error. And exception 4, and it says there's been an exception that a, the character a, is not a valid integer value. This is mimicking the sort of problem you might get if you wrote an application that takes, for example, input from the user. You can't prevent the user putting in the incorrect sort of input. They might put a character, an alphabetic character, for example, when you're expecting an integer, and of course if you then try to do some arithmetic, it's going to fail. So let's have a look what's going on behind the scenes. Exception 1. This is a very simple exception handler. The code that might cause the exception, for example, if you took input from the user and you try to do some arithmetic, I would enclose that between the keywords try and except. Here my code deliberately causes a problem by trying to convert a character into an integer. It's caught by the exception handler, that's between except and end, and all it does in this case is it says there's been a problem. Now the exception handler for button 2, that's a little bit more complicated. As you can see, this time it has multiple on, and then there's the exception name and followed by do, and it has different behavior coded into each section of the exception handler. So if I get an e-convert error, that is if I try to convert the string in this case to an integer, that's what happens. I get an e-convert error and it says there's been a conversion error. So let's just remind you that's on button 2, there's been a conversion error. Button 3 says there's been a zero divide error. Let's look at the code for button 3. This has the same set of on, exception, do sections, but this time I've tried to divide n1 by n2. Now n2 happens to be have a 0 value, so it's caused an e0 divide error. So the first section here, e-convert error, is bypassed because that does not match the type of exception that is raised. The type of exception that's raised here is e0 divide, so it's this section that displays the message. When you're writing exception handlers with multiple sections, as I've got here, you should put the most specific type of exception first and have the more generic type of exception last. So exception is the ancestor of all other exceptions. So if neither e-convert error is matched nor e0 divide, then on exception do will execute. That mops up any other sort of exception for which I don't have a specific exception handler. So to summarize, the syntax here is try, then the code that might cause some sort of exception, then except, and between except and end I can put optionally multiple exception handling sections, each of which specifies a specific type of exception class. Now to find out about these exception classes, you can highlight in Delphi the exception class name and press F1, and that will pop up the Delphi help system, and here you can find more information on the exception class, and you can find more information on exceptions in general by clicking the various links in the help system. You can do the same thing in Lazarus. This is the Lazarus help, and this gives you the information on e-convert error in this case, shows the inheritance. E-convert error descends from exception, and exception ultimately, like all other classes, descends from t-object. So, to reiterate, if you've got a specific type of exception like e-convert error, then you need to put that higher up the list of exception handling sections, and the more generic exception handlers such as on exception do to mop up the more generic type. And finally here I've got an example where I initialize a variable of the exception type. This is optional. You can put the variable name followed by a colon followed by the exception class name, And when that happens, you can then use the variable to use specific features of an exception object. Now, one of the most useful features of an exception object is message, and each exception object comes with a message which describes something about the exception. So my string here just says there's been an exception, and I append to that e.message. Let's remind you what you actually see. So it says there's been an exception, and it's the message property of the exception object which displays A is not a valid integer value. So that's another useful thing to have in your exception handlers. Now, one thing I should just mention in passing is that in Lazarus, the zero divide error is not always trapped. So I've had to take some extra measures in this code which handles the zero division error. The reason this is not trapped is explained in the Lazarus wiki, which you'll find online, and there's a note to find that in the little book of Pascal, and it explains about some cross-platform issues that are handled in a different way from Delphi, because Delphi is not cross-platform as Lazarus is. And so one of the consequences, for some complicated reason which we needn't go into here, is that zero divide errors are not handled in the same way by Lazarus as they are in Delphi. So what I've done here is I've just tested, is the thing that I'm trying to divide by n2, is it 0? And if it is 0, then I show a message, can't divide by 0, else I do the division. So it's a good example that exceptions are not the only way, exception handling is not the only way to avoid unforeseen errors. In fact, here you could say that it's not really unforeseen, I've foreseen the possibility that somebody might enter 0, and I've taken evasive action. So this is an example of defensive programming. I'm trying to defend my program from possible crash situations that could occur in certain situations if somebody does something which is going to cause a problem which the code can't deal with. So try to build in these sort of defensive actions into your own code. Don't rely exclusively on exception handling. Exception handling is useful, but it's a good general principle also to try to defend your code by foreseeing possible error conditions and taking evasive action.